start. So the slip roll is an awesome piece. Because of the length of the rollers, we can roll, I think, up to a 50-inch wide piece of sheet at any given time. We won't be probably using this for that application in this class, but as you can see down on the edge here, we have 3 different grooves. If you're looking for very particular curves, circles, or just want to test it out and see if it's what you want to use, please feel free. 1/4 inch, 5/16, 3/8. Those are the 3 different sizes you can roll in here. You can't roll bigger sizes in a smaller one, but you can roll smaller sizes in a bigger one. Meaning that I could roll the 1/4 inch in 3/8. There's no reason to because there's a 1/4 inch slot, but I could take the 1/8 inch or the 3/16 and stick it into the 1/4 slot, no problem. But I'm not gonna grab the 1/2 inch and try to roll it into 3/8, right? I'm not gonna do that. Y'all aren't gonna do that? Good. It will create grooves in this roll, and then that's something we can't fix. This is a heavy piece of machinery. I welded the stand on it and put these heavy duty wheels on it. So it rolls pretty easily, but it is heavy. So it takes a little bit of force. You wanna kind of get it out into space. And I'm gonna kind of have it diagonal like that. Likewise, when you start to use it, I would lock these down so that it doesn't start to roll on you as you use it. And if you need to modify how you've locked it down, just clip it, roll it. Again, being mindful of who's around you in space, who's using the equipment over here. Probably nobody's going to be over here, so you can even pull it this way a little bit. But if there's somebody on the vise, using the vise, you'll just have to kind of do it. I think I took the piece that I was going to roll, so I'll go cut a piece really quick. So somebody get out your calculator really quick. And let's say I wanted a 12-inch diameter circle. Anybody know how to figure out the circumference of the circle using the diameter? Anybody remember math? What is it?
The area is 2 pi
what?
r.
2 pi r, yeah, so what 2r is the diameter, right? So if I want a 12-inch circle, what's pi?
3.6.
4 times 12, that'll give me an exact number, which is what?
75.39.
What?
Is that right? No, that's wrong.
Can't be. Try it again. That'll give me a really big circle. Oh, the diameter is 12. Radius is
6.
right. So, well, you would just say 12 times 3.14. Yeah.
You should be good at this.
You're fine on that one. I already
37.
Yeah.
Like 2 pi, alright. But I should have. I tried to R, not E. I hate this. Kicks my ass every time. You see, I was an engineering freshman year, so I should have this shit on lock.
Boom, crash, bang.
Okay, so what I did is I actually added a couple of inches to that. And the reason I did that is pass the circle around and tell me what you see at the very ends.
Kinks.
Kinks? You're right. That is what you see. I was just messing with you. Hold on. What did you do to my circle?
It wasn't. You just gave it to me.
Does everybody see it? About how far in do you see that lack of curve?
2.
You see where it is there, Cadence? Yeah. So about 1.25-ish in, it doesn't bend. Meaning that if you're looking for a perfect friggin' circle, you're gonna have to add about 1.25 to each end. So I added 2.5 inches to that 37 point whatever, because I know that when I get done with this, they're gonna overlap. I'm gonna clip those off and weld them together. If you don't care, and it has a slight flat edge at the very end, then no big deal. But the last about 1.25 is not gonna bend. So keep that in mind. When you come up to this machine, couple things to keep in mind. And you can bend down here. The gap here, number 1, should be parallel. It should be the same on both sides-ish. You don't have to get a tape measure out. And you don't want it more than like a heavy 1/4 inch. So right now it's perfect. It's okay to go up a little bit, and it's okay maybe to go down a little bit, but inside of that gearbox, this roller has a gear, and if this gets dropped too far, the gears separate and it won't roll anymore. Okay, so you really don't want to mess with this one. Somebody always messes with it, and I don't want them to. A lot of times it'll just be pinched all the way up, or it'll be dropped down so far that it comes out of its configuration and it doesn't work. Try your best to leave this alone. 1/4 inch is a good gap. Again, you can go slight modifications if you want, but for the most part, this roller does not move. The way to make it move are these two knobs. They're in the front of the machine. And the reason, it's not malicious, the reason people mess with these is because they look exactly like these two knobs in the back of the machine, which control this roller back here. This is the one you move. So this one stays fixed. I mean, it rolls, but it doesn't go. This one you can move, but really we don't want it to move. The one in the back is the one you move. And I'm loosening it and dropping the roller, so everybody come check it out as I lower it down. All right, that's probably good right there. This whole roller drops down, and the reason I'm lowering it right now is so I can start with this piece being able to be slid through without much friction at all. Because if I put my guy here, I can roll it, but because this roller isn't really pressing up against it, as I get through, it's not really gonna do much at all, okay? So now, this is how I wanna start. Now I'm going to take 1, 2, 3 turns. 1, 2, 3 turns. 3 is arbitrary, it doesn't really matter. But the fact is that I'm doing the same exact thing to both, meaning the roller's going up at the same distance. You don't want to just be cranking here, because then the roller goes, wonky like that, and it's going to could give you a spiral possibly. But I'm looking for a circle today. So then I push this up to the roller. Now I can still actually push it through. So knowing we only have so much time, I'm going to do 3 more. Because this will start to bend the steel at a slow pace, but then it'll pick up as you go. So what I did is I started it, and immediately I'm grabbing it here because it could go that way or the other way, which isn't detrimental, but I want it in the same plane. I want it to roll in the same plane. So I'm going to hang on to it as it goes, and I'm just eyeballing it in the same plane. Go all the way through. I've started my arc. If this is what I wanted to stay with, I'd stay with this, but I want a circle, right? So I'm going to go 1, 2, 3. 1, 2, 3. Now it's really important to keep it at the same, in the same plane. Sometimes it helps to have a helper. Right? 2, 3, 4. Let's see if I can do this. If you pick the roller up too far, too fast, you won't even be able to start it, because the amount of space in there is too tight. The roller won't be able to start it, but yeah, just put a little bit of force into it. I'm getting close. All right, let's go 1, 2. 1, 2, because I don't really want to go past the point too far, because you can't really fix it. 2, that might be too much. It's still off a little bit, just because I'm going fast. And, it's easy to get off a little bit, which I can just kind of do like that and I'll be fine. Uh-oh. Too far, you guys. I'm holding it back a little bit so I can get it out of here. Yeah, I went too far. So because of the speed of that, I probably should have just done 1 turn, and I could have gotten that circle. So this isn't a lost cause. I would just want to bend it out as equally as I could in certain areas, and probably continue to bend in certain areas. And I could make that work, definitely. clip, weld, continue to manipulate, and I get that to work. The reason it's called a slip roll, let's say I wanted to keep going, and make a tighter circle, because I know you guys, somebody's thinking it. Put it into that slot right there. So it's got a spot to go into. It's locked in there forever. It's not. Slip roll, so you move this up, you slide this whole roller out of place, and you get your piece out like that. It's going to be tighter than 12 inches. Move it back up, drop that down. Please don't leave that for somebody else to find out. That's why it's called a slip roll. One last thing. There's two different gear ratios for this machine, okay? The one I'm using is a 5-to-1, meaning that it goes slow, but I have a lot more strength, a lot more force, a lot more torque. It also has a 1-to-1 ratio as well. It goes a lot faster, but you're not gonna be able to bend as much as quickly, okay? The way to do it, if you want to, is you can't just switch this guy up here. You have to disengage the 5-to-1. So this little lever, it goes up, you push it out, and the gears just went like that. This whole post went out of gear, and now the 1-to-1 is set up. Look how fast it goes. Right? So you can move a lot faster with your bending, but you just can't bend as much. It's a 1-to-1. You're not going to have as much strength for your bends. Okay.
It reverses.
If you want to go back to the 5-to-1, you just lift this up. As you pull, you're going to have to kind of move it to make sure that it gets into those gears. And we can go back to this. Most people are going to want to use the 5-to-1, even though it takes longer. Most people are going to want to use that. Yeah. That's it for this machine. Any questions about this? Okay. How did I do? What time is it?